Now we're talking about trigonometric ratios. Trigonometric ratios are all about right triangles and how each piece of a right triangle is related. Here we have a right triangle. Right, we'll label the right angle. And what you need to know about a right triangle is that all of these sides are related to all of these angles. So if we label our right triangle, let's say A, B, C. There are ways in which the angle A is related to the side AB and the side BC and the side CA. And the way that those things are related is through trigonometric ratios. And if you think about it, it makes sense, right? The degree of this angle is going to be related to how long this thing is, right? How long this is, and how long this is in some sort of ratio. And that ratio is called trigonometric ratios. So the first thing I want to start off with is something called SOHCAHTOA. And you're going to want to memorize SOHCAHTOA. SOHCAHTOA is a mnemonic device for remembering your trigonometric ratios. And here's what it's all about. Sine of any angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. And we're talking about lengths here. So sine of an angle is equal to the length of the opposite side over the length of the hypotenuse. The cosine of an angle is equal to the length of the adjacent side over the length of the hypotenuse. And finally, the tangent of an angle is equal to the opposite side divided by the adjacent side. So those are your trigonometric ratios, and as you can see, SOHCAHTOA comes from sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. So that's why SOHCAHTOA is a good thing to memorize, because that tells you all of your trigonometric ratios. And just to be clear, here's what we're talking about when we say sine opposite adjacent and so on. If we go back to our right triangle for a moment, and let's say we're talking about this angle, angle A, related to this angle, this is the adjacent side. Okay? This is the opposite side. And this is always the hypotenuse no matter what we're talking about, because it's opposite the 90-degree angle is the hypotenuse. So the adjacent side is the one that's adjacent to the angle we're talking about. The opposite side is the side that's opposite, directly opposite the angle we're talking about. So adjacent and opposite will switch if we're talking about angle B instead of angle A. If we're talking about angle B, all of a sudden this becomes opposite and this becomes adjacent, right? Because this is the one next to angle B. That's the one directly opposite angle B. So that's something else to keep in mind. So how does this all come together? Well, let's look at a triangle. Here we have another right triangle. And we have some side lengths. This is going to be 8. This is going to be 17. This is going to be 15. We'll call this A, B, C. And if I ask you, what is the sine, and we're going to shorten sine to just SIN, and that's the way you can find it in your calculator, of angle A, I know that sine is equal to opposite over hypotenuse. Opposite in this case is 15. Hypotenuse is always the one across from the 90-degree angle, so 17. So I know the sine of angle A is 15/17. I know that the cosine, and we're going to limit that to cos, of angle A, which is equal to adjacent over hypotenuse, is 8/17. And finally, tangent, we'll call that tan, of angle A, is equal to opposite over adjacent, so 15 over 8. And those are your trigonometric ratios for that triangle. You don't always know all of the sides, though. So instead of finding the sine of an angle, sometimes you need to find the side of an angle, or the side of a triangle using an angle. So let's look at what that might look like. Here we have another right triangle. We know that the hypotenuse is 14. We know that this side is x. We know that this angle is 48 degrees. And let's say we wanted to solve for x. Well, we're going to use our trigonometric ratios, and we're going to say that the sine of 48 degrees, which I don't know off the top of my head, I'm going to have to use my calculator. And if you look on your calculator, you'll notice there are 3 buttons, sine, cosine, and tangent, right there. And you can use those. Tip, make sure your calculator is in degree mode, and you can check that under the mode menu. It sometimes sets to radian, and you want to set it to degree. So make sure your calculator is set to degree mode, okay? Otherwise, this won't work. The other big caveat for this work is I'm going to let you write your answer in rounded decimals. I know that's a shock. I know I don't normally say that, and there aren't a lot of other instances where that's going to happen. But for this one small sliver of calculations, you're allowed to use decimals as answers, as you're going to see in this next problem, because the sine of 48 degrees is no small decimal. It's actually a really long decimal. So we're going to set up the ratio here. We're going to say the sine of 48 degrees, and the reason we're using sine is because we're interested in the hypotenuse, and we're interested in the opposite side, and we know the hypotenuse. And sine is the one that relates opposite and hypotenuse. And it says sine of 48 degrees should be equal to the opposite over the hypotenuse. If I want to solve for what the opposite is, then I have to multiply both sides by 14. So I get 14 times sine 48 equals x. And we can write that right in our calculators. We can say 14 times the sine of 48 degrees, and what you're going to come out with is about 10.4. That is a rounded decimal answer. I know, shock. And if you try this problem on your calculator and you don't come with that answer, please check your mode again and make sure you're in degree mode. I can't emphasize that enough. If you're not in degree mode, none of this is going to work for you, and it's going to be very frustrating. Okay, well, that's it that you need to know for the problems you have due over break. Try these out. If you have any questions, you can email me. There's lots of information in your book too, so I'm going over a lot of information. You might want to listen to this video a couple of times. I'll keep it without questions so it's easier to rewatch. But read through your book too, look at the problems, give it a try. You can do a lot of this work in your calculator, so please have your calculator with you. And I can't emphasize enough, make sure you're in degree mode, not radian mode. Enjoy.